Let's get started with our first keynote speaker, Andy Knight. Yeah, you can go and give him a round of applause. I'm going to do an intro. Y'all can applaud for him. I'm going to go through this really quick again and then tell you how I met Andy. So Andy is also known as Pandy, or Pandrew if you're in a formal setting. Is the automation panda. He is the software quality champion who loves to help people build better quality software. In the past, he's built large-scale test automation projects that run continuously and reliably. Good for you. My code doesn't run reliably or continuously. Currently is a developer advocate at AppleTools and director of Test Automation University. Pandy helps folks make their apps visually perfect. He serves, I should just read what's on the slide instead of getting ahead of myself. He serves as director of Test Automation University, which offers a multitude of free courses on software testing from the world's leading instructors. An avid supporter of open source software, Pandy is a playwright ambassador as well as the lead developer of for Boa Constrictor, the .NET screenplay pattern. On the side, he is writing a book on software testing with Manning Publications. You can check out his tech blog at automationpanda.com, and you can follow him on Twitter at automationpanda. So I met Andy here in 2019. It was one of the first conferences that I had ever really started speaking at. I think that was your first year at PyTexas too, is right? Yeah, so myself, Andy, and then a couple of guys at this table, we all met, and then we basically kind of toured the United States together. We all kept going to regional Python conferences. We saw each other here at PyOhio in Columbus, Ohio. We saw each other at PyCon. That year was in Cleveland. We saw each other at PyGotham, except for Ollie, who went to party in the EU, which was fun. At PyBalkans, that was a really interesting conference. I think they went to PyColorado, and I didn't get to make it. So the point I'm trying to make here is you will make friends at conferences, and they'll stick with you for the rest of your life. Conference friends are real friends. It's a real pleasure to get to have Andy come and give a talk today. You know, he's spoken at PyTexas every year since 2019 that we've had a conference. And yeah, just one of my really good friends. I'm super excited to get to introduce him to you. And I already know what the topic of this keynote is, and I'm really excited to watch it. So without any further ado, let's welcome Andy to the stage.
Thank you so much to the organizers, to Mason and the crew. It is truly an honor to be on this stage again for the third time in person. And this is also my first Python keynote. So I'm very excited to be here. Thank you. Something that's really cool about software is that we can basically build anything with it. I remember I started programming 21 years ago, freshman in high school, on a TI 83 plus calculator. I was making math formulas, and I'm like, this is the best thing ever. And my mom says, you know, that's what I do for a living. And I'm like, what? You get paid for this? Right? And then the more I studied programming and ultimately a computer science degree and getting into the industry, I realized it really is almost like this superpower. We can build web apps, we can build mobile apps, we can build irrigation systems for house plants, we can build amazing blinkers on your cosplay costumes with things like Adafruit. We can solve world problems that are meaningful or just keep ourselves occupied when it's really bad outside and everybody's got COVID, right? It's awesome. Hardware plus software, you can really, really just let your mind run wild with creativity. Big challenge, though, is the question of how do we do this? Because there are many, many ways that we can build the awesome things that we want to build. Just looking at languages alone for programming, because programming languages are primarily the main means of which we communicate with these things we call computers or machines or whatever we're calling them now, devices. Remember when all of a sudden we stopped talking about computers and started using the word devices? Am I this many years old? I think I am. But here, I'm guessing most people are probably familiar with Python, right? But I'm guessing many of you have also used these other languages. C#, anybody? Yeah, my previous job, I was a .NET developer. I would go to Python conferences, talk about Python, be like, so Andy, tell me how you use Python in your day-to-day. I'm like, I actually use C#. And they're like, oh, you're not joking. I'm like, no, I'm not. C# is good. C# is like a Cadillac. It's very nice. Ruby, anybody? Yeah, a little bit. Okay, I heard that Ruby's not dying. That's good. Perl? This one might be a stretch. Sweet. A decade ago, I spent 4 years at NetApp. I did nothing but Perl test automation. Why? Why did they do that? I know why. It doesn't make it better. JavaScript, many people, yeah. Java, yeah, I mean, if you went to school through the 90s and thousands, you got indoctrinated in Java. PHP, yeah. Rust is having a darling moment in our community. C++, yeah, I feel y'all. Go, yeah, so I mean, I'm sorry, this is for my own vain curiosity, but there's tons of languages we can do. And it seems like every language has a set of tools and frameworks and stuff that you can do with it. But also, even though these are all technically general programming languages, they seem to all have a set of domains that they're in, right? Like, oh, you would use JavaScript for front end, or you would use Perl for regular expressions. Ruby, I don't even know what you use Ruby for anymore, I'm sorry. It's a little early in the morning. I'm not trying to take a dig on Ruby. Ruby is cool, but we're at a Python conference. So there's many, many ways that we can choose to build these awesome things we want to do with software. It's a fairly common phrase in our community that Python is the second best language for everything. I'm sure people have heard this before. And I did not originate this. I'm not going to take credit for this. I heard this very early in my Python journey, and I was like, oh, okay. It's a very common saying, but what I want to do today is I want to challenge this. Because in my opinion, I believe that Python is the best language for doing everything together. Oh. Yeah, I believe that Python is the best language for doing everything together. Because software is not something that we implement in little tiny bubbles anymore, right? We're not really just trying to make a cool little program to poop out math formulas to help us with our homework, right? We're solving world problems. We're trying to bring value. We're trying to make the human condition ultimately better, I hope. At least that's my goal. And so today what I want to show you is full stack Python. How we can use Python to make amazing applications through and through, full stack, pretty much entirely within the one language we love the most, Python. And how I'm going to do this, I'm going to show you a project where I've tried to do this. Now, it's not anything grand, but I think it's pretty cool. I'm going to show you my bulldoggy reminders app. Isn't it cute? Sorry, I don't have stickers of this. I probably should have thought about that ahead of time. If you want to check out the code, I have it on GitHub. GitHub.com/automationpanda, that's me, /bulldoggy reminders app. I've got a QR code on the screen. Now is your chance to, I'll just stall for another moment or two while people take a look at it. You can run it yourself if you got Python on your machine. Yeah, pretty cool. So, let's take a look at what that app looks like. I have it running on my machine. Can everyone see this okay? Yeah, good, okay. Projector's not dead. So here is the bulldoggy reminders app. It's running locally on port 8000. And there's the login page. So I'm gonna log in. My username is Pythonista. And my password is iHeartTesting. I mean, y'all know. We log in, and here we are. Oops, I didn't clear that. Sorry. And here we are. This is what it looks like the first time you log in. You've got a nice little top banner card. You know, it's got your username. Oh, it's reminding you who you are. You've got a log out button if you want to get out of here. But then you've got a set of reminder lists. I'm sure y'all know I'm a very busy person. I go all around the world to tell people about stuff now and run TAU and do all these other. I can't remember anything. I need reminders lists. So, what do I need to do? Well, I have a set of chores that I have to do. Okay, so I added my first reminder list and it's now highlighted. That's cool. If I wanted to, I could edit the name of this. Yay. But I'm not going to. We'll just leave that there. Now, what are some chores we have to do around the house? We have to walk the dog. We have to mow the lawn. We have to buy groceries. I don't know. That's good enough. And when I do something, I can check it. Boom, it's stricken. Or, oh crap, no, I didn't do that, that was a mistake. Okay, no, I actually did, boom. Right, I can even delete things if I don't want to have them on my list anymore. You know, I can add even more things. What are some chores we have to do? Dishes, wash the dishes, take out the take out the trash. Yep. So I mean, there's a bunch of cool stuff we could do. I heard something. We already did it. Yeah, there we go. That's not a chore. That's a pleasure, man. Come on. So anyway, I got some chores. That's all really cool. I could also, maybe there's other things. It's not just chores, but there's also projects I have to do around my house, because holy crap, I've got projects. I have to tune the carburetor in my Volkswagen Beetle, because that's like witchcraft apparently. I have to install a decoy owl to scare away the woodpecker that pecks on my side of the house at 6 a.m., right? Anyway, you get the idea of how this thing works, right? Pretty cool. What I'm doing here is like there's actually like dynamic interactions. Like it's not like it's submitting a whole formula backend and reloading the entire page. It's all like happening like a modern, real web application. And when I'm done, I can refresh. There's persistence. Like it's saved there. That's really cool. And I can log out when I'm done. Woo! So small little modern web app. What do we think, y'all? Yeah, it's really cool. I was very pleased with myself when I did this, probably more so than was due. But it's exciting when we build cool things, right? That's why we're here. It's super exciting to build cool things. You know how I built that? Full stack Python. Woo! You got the answer right. Yes. So let's take a look to see how we built this thing. All right, so I have my project here. It's, like I said, you could be looking at this locally on your machine if you got the GitHub repository, or if you just go to the GitHub website. I've got it open in Visual Studio Code. I like Visual Studio Code. It's cool. So let's start with the model. There is persistence happening under the hood. I have this in my storage. Oh shoot, I should probably back up and explain the structure of this project, my bad. How I built this app, yes, full stack Python. It's fast API, it's HTMX for those dynamic interactions, and I'm using TinyDB as my database for storage. So in my storage layer, or my persistence layer, the reason I'm using TinyDB is because this is meant to be a demo app. I'm not sending this to production. TinyDB, it's like a document type database that stores your data in a JSON file. Ultimately, I'm going to use this application in a book I'm writing, so I need to keep it very, very simple. Simple is better than complex. So if we look at the storage layer, there are essentially 3 models that I have, and I'm using Pydantic to model those things. I could use data classes, whatever, I'm using Pydantic. You have your individual reminder item. That would be like the buy groceries, walk the dog kind of thing. There's an ID for it, the list ID for where it belongs, a description, and whether you've done it or not. There's also the data model for the reminder list that has the connection of all those reminder items, and that has an ID, an owner, that's the user, and the name of the list. This is very, very, very simple. And then also there's the model that holds the selected lists. Like when you saw, I could have either the chore selected or the project selected. I put that in the database too as well for persistence. So not too much going on with the data here. Then I just made a class that holds a reference to your TinyDB object and then does things with those models with the database. Like you can create a list and it goes in and creates this dictionary, which then inserts it into your TinyDB document-based database. You can delete a database, or wow, no, don't delete the database. You can delete a list. You can get an individual list. You can get all the lists. Everything is based on you as the owner, because in theory, this app could have multiple user accounts, therefore multiple owners. You can update the list's name. You can add items. So like fairly boilerplate kind of CRUD operations here. So that's going to be persisted on whatever machine you have it on. You could use something like SQL Alchemy with a real database. That's cool too. Ultimately, though, you need some form of persistence. So that would be what we would call like the model. Now, in terms of what we're going to be viewing, those are the main pages. And there were 2 pages we saw. There's the login page as well as the reminders page. The way that it works with Fast API is that I have these routers that control your API resource path. So when you say, hey, I want to get the login page, FastAPI receives that path, and it's like, okay, well, let me go find the function that's going to, oops, I'm going to log in. Here we go. I need to find the function that's tied to that login path, and I'm going to run that and then give you the response, and hopefully the browser shows something pretty. So here in my router for my login, I've got this getLogin async function. Ooh, async. FastAPI, what did you do there? But anyway, on top of this function, I have my decorator for the router for a GET request, because with this GET, POST, PATCH, PUT, all those things, the HTTP methods. This one, we just want to get a login page to show it. The path is /login. That's cool. I've got some stuff here for docs that we'll see a little bit later. But ultimately, when I get my request, or call my login, there's a request object that's associated with that, maybe some other parameters. Don't worry about that. They are optional. Typing. Ooh, right. So anyway, I get my login request, and what's happening here? The code I have bundles together like those options and the request for context, and then it will return a template. Now, I'm guessing many people have probably done some Python web development like Django or Flask, maybe FastAPI. It's a fairly common pattern that if you want to show pages, that you wouldn't just puke raw HTML here, that you would use a template file. And then you can insert things into that template to parameterize it, and then you would send that response back so it can display a page. With FastAPI baked under the hood, you have Jinja templates, which are very similar to Django templates. I actually started with Django. I moved on to Jinja. I couldn't really tell the difference. That's just me. So in my template here, I have a template for my login page. And then if I go to my templates directory in my project, I have a login HTML template. Fairly boilerplate. This is almost all HTML, right? Hypertext markup language. So I set things like the title card here, or no, sorry, that was, it's still a card. It's the login card. It's got the name, bulldoggy, the reminders app. It's got that really cool logo. So happy with that. Then we have a form, basic HTML form, where we put in username, password, and there's some template-y stuff here for some of those options. That's cool, that's cool. Same thing is for the reminders. So if we go to the reminders router, here we go. This is a separate file, reminders py. I have my router, prefix everything, /reminders, so we know where we're at. And similar kind of thing. If I want to get the reminders homepage, get, remember I had that prefix, so the path can be /. So if I go to my, whatever my base URL is /reminders, I'll get to the reminders page. The only fun thing about this is that there is some authentication, right? Remember we had to log in. I don't want to go too far down to authentication. TLDR, authentication's a nightmare. Yeah, we haven't figured this out yet. I mean, we figured it out in many ways, but we haven't like really figured it out good to make it easy enough for people to use, like just like that. You have to go learn about it and then really use it. Maybe that's a good thing. Maybe you should learn before you do something. I'm sorry, rambling now. All that to say, what I've done for this authentication is cookie-based authentication. So it's like somebody logs in, they send a request, with the login post, I send back a cookie if it looks good. There's a JWT token in there, and then it just gets magically stuck on the browser. And so then with FastAPI, you can use this depends thing to like go fetch whatever your storage was for that cookie. And then from that, get your username, and it's all protected, I think. Again, fairly complicated down there, but just trust that this gives you proper authentication and tells you like what the storage object is, which has the username in there. So I build the full context for everything I need on the reminders page, which has just kind of data, essentially data I need to stuff into my templates, like what were the actual lists and items and the ones that's selected. And then I would return that reminders template, which is going to be different than the login template. Reminders template is here. Again, mostly boilerplate HTML. We have a title card with that nice little bulldoggy thing at the top. Interesting thing here, this is the magic of templates versus raw HTML. If you remember, there was that piece that said reminders for Pythonista, my username. Here, I'm substituting my username in here. Yay, templates! Yay. Very cool, very cool, very cool. Yep. So that's all right. Then I also have an include. Another cool thing about templates is that you can include templates inside other templates. Code reusability, don't repeat yourself. So if we look inside the content, there's even more templating stuff going on in here. So this is where we have those cards, the reminders list and the reminders items. This one is the reminders list, and so what's saying here, we have a for loop in our template so we can pop out multiple rows. For each reminder list that you have, create a reminder list row, and that's how it could go kaplunk, kaplunk, kaplunk. Analogous for the item side. Very cool. So let's take a look at this list row. List row HTML, again, this is a template, but now there's some extra funky things we might not recognize in here. So if we look at this, I can even go back to the bulldoggy app and we can log in again real quick just so we can see. Heart testing. Like when we had these rows, it's like every time I could add a new row, and there would be new lists of things, right? So each list row is, that template is creating that new HTML snippet for each new list row. That's why we put it in a for loop. And so in there we have a div that has a certain class, so it has all that nice styling that's going on in it. I'm giving it a data ID just for selectors. Yes. We have a paragraph in there that has the name of the reminders list, and then we have those two images for like the edit button and the delete button. But then there's all this HX stuff. What is all this HX stuff? This is all using a tool called HTMX. Has anybody used HTMX before? Yeah, a couple people. Okay, so this is where we can really become full stack Python. Because for years, JavaScript has had a monopoly on the browser. Right? You gotta do some JavaScript if you want the modern cool stuff. And that's not bad or wrong, it's just the way it is. But I'm in Python, I can do JavaScript, but I'd like to kind of keep it full stack Python. With HTMX, what you can do is you can do JavaScript-y-like dynamic things without having to directly code JavaScript. And the way it works is that each of these attributes, what they're doing is they're indicating what should happen when you interact with this element. When you interact with an element, say that you click it, maybe you want to send a post request to your API to get back a different body of hypertext that you want to substitute on that page in its place. Basically how it works, it's just let's swap around some hypertext. We don't necessarily need to do JavaScript to do that. I mean, we do because the browser requires it. But we can also use this tool called HTMX where we can literally just keep it all directly in hypertext. And underneath the hood, HTMX will take care of all the AJAX and stuff. But for our programming perspective, we just straight keep it in HTML. And then the API, behind the scenes, we can write in Python. And so that's how I've implemented the bulldoggy app. All those dynamic interactions is literally just HTMX requests throwing back more hypertext from my fast API service. So if we wanted to look at one of these, for example, like if I wanted to click on that edit button, meaning I wanted to say, okay, I have a name of a list and I want to edit it. I'll click this button. And then what happens? It changes that from a paragraph to an input field that I can now, whatever. Right? The way that works in the code is, okay, well, I'm here. If I were to click on this particular image element, I want to trigger an HTTP GET request to this different endpoint, which reminders list row edits with the ID of my particular list. The target value is going to be the input value that I got from this particular input field. And then once that's complete, I want to swap outer HTML, meaning this entire element that is targeted, I want to just rip that out and put a new thing in its place. The target is this this particular div here. The data ID, reminder row, list ID, HTMX target, the CSS selector for that particular one. What that means is, yes, I'm going to call this, and whatever I get back from this call is going to replace this entire div on the page. Oh, does that make sense to everybody? It's pretty cool. So if I were to look at what this particular resource goes to in my app, reminders list row edit, I can go back to my reminders, list row, I have to scroll down, here we go, get list row edit. Boom, here we are. And so what does this do? It gets that list ID and then it does some magic stuff and essentially returns another template. Right, okay, so what does this template look like? List row edit. List row edit. Oh, look, this one now, that div is still there, but instead of a paragraph, it's now an input field. That's how I was able to start typing in it, right? And so what if I wanted to commit this? So I have my check circle, same thing. Well, I'm going to now, when I type something into that input field and I check, it's going to fire off to the patch of that resource path, including the value that was put into this input field. Any triggering of that's a click or an enter up is going to send this request, and I'm going to target that whole reminders grid and swap that out. And so you can see how now with this, you're literally just playing with hypertext. Right? The fast API part is fairly minimal. It's almost boilerplate-ish. You're just being like, well, I do this interaction, and I send this content. Well, if I do this interaction, I send this content. That is the power of HTMX. It's pretty cool, right? Yeah, there we go. Okay. I think it's pretty cool. I mean, pretty much all the interactions on the page are like this. We don't need to step through every single one. But we kind of have an idea of like, oh, like I don't need to like code some JavaScript in the browser to get it to come to life. I can make it come to life like this. I mean, when I was showing you the app, you probably thought it was just like any other web app, am I right? Like, oh, you didn't even know what HTMX was maybe. It's like, oh, but this is a really cool thing. It's seamless. I found that HTMX can probably get you 90 to 95% of the way there. And for the remaining 5%, just use Alpine.js, and you still don't need to use JS. This does not use Alpine, because it didn't need to. So that's all really, really cool stuff. Now, we focused mostly on what we would consider like front-end stuff, like the visuals of this web app. I mean, Fast API technically has the back end because it goes to the server and comes back. But what if you wanted to do more kinds of back-end things? Like, hey, what if I, instead of having to like, enter everything in as a human, what if I wanted to just use an API to create lists and create list items? Can we do that too? Why, yes. Yes, you can. Why? Because Fast API is basically got this whole REST API support built into it. When you make your endpoint, or when you make your routes with Fast API, it basically turns them into REST API endpoints and that are OpenAI, or not OpenAI, oh my gosh. Whoa. Open API compliance. So here is the automatically generated docs page from Fast API. It's given to you. It's pretty awesome. This is honestly one of the reasons why I wrote this in Fast API rather than Flask, because this just comes out of the box. And so if I wanted to check, like, hey, how do I use the API in order to do things? Like here, I can get all the API reminders. It's already authenticated, so I can try it out literally in the browser. If I were to execute this, look, these were all the reminder lists that were in my app, right? Same data, same authentication. Woo! So I can not only use this as a human, but I can now use this as a machine through the API. Still all Python. It's pretty cool. So what about testing this thing? I mean, come on, you can't have an automation Panda talk without talking about testing, am I right? Like, duh, like, you knew it was coming. I know some people are like, well, nobody likes testing. I was like, you know I'm here. You know I'm here. You can't miss me. Let's see what it looks like to do some testing of this thing. It is no secret that my favorite test framework is PyTest. And that's not just in Python. That is across the board. And y'all know I travel way too much around the world, and I'm involved in way too many of those different language communities and the testing community. I have done almost all in regards of test automation. If there's anybody on this planet who can say they've done almost all test automation, it's me. And PyTest is my favorite framework. Amen. I've got stickers if you want them. Why? Because there's some really awesome things that PyTest does that's very different from other frameworks. We can talk about that after. Anyway, so I have added tests to this project in order to test it. And not just unit tests, because a lot of times I think in Python community when we talk about testing, we think, oh, like unit tests, right? I'm talking not only full stack Python, but full stack testing. We're going to have unit tests. Yes, unit tests, API tests, and UI tests, all in PyTest, all in this project, all covering things. So I have a directory called tests in here, and inside of there, I've got 3 modules, test unit, test API, and test UI. Right now, there's only 1 test of each type in here. I haven't had a whole lot of time to really build this out yet. It is a work in progress. But I do want to show you, like, here is a basic kind of unit test that we could have for this project. And what this is testing the authentication token serialization. I have my test function in PyTest, meaning this is a test procedure. All I'm doing is I'm saying, hey, with a particular username that's given to me by a fixture, that's part of setup, serialize the authentication token for that user's username. Make sure you got it. Make sure it's a string, and make sure it's not just the username itself. Then deserialize it and make sure you get the username back. Pretty straightforward unit test, but very valuable, because if you screw up your authentication, ain't nobody going to be able to record reminders. Now, we also have API tests, because we have that whole beautiful API behind the scenes. And so what I'm doing here is I'm just testing, can you do a basic login of your credentials via API? So I'm doing this is using the Playwright module. Oh, I should back up. The unit test was just pure PyTest. But if you want to do black box testing, you need other tools. If you want to do API testing, you can use requests for that. Or if you do API and UI testing, you can use a cool new library called Playwright. Has anybody heard of Playwright? Yeah, some people have. Okay, good. I mean, historically, we've used Selenium in the Python community, and Selenium's great. I actually just came from Selenium conference. But I think Playwright is awesome. I am actually a Playwright ambassador. I can give you stickers of Playwright if you want. Playwright is a more modern test automation tool, or framework if you want to call it that. It handles a lot of things for you automatically, like waiting and browser setup. It's really, really nice. If you have to do any browser automation in Python, I strongly recommend use Playwright. It's really cool. Nice thing about Playwright is, like, well, Andy, that's like web UI. We're talking about API. You can actually do API testing with Playwright as well. And it's really nice because they can share credentials with your UI tests, so that, like, oh, well, you need to log in only one time, and the API and UI can use it all together. Woohoo! So cool. So, and I'm pretty sure underneath the hood, Playwright and Python uses requests. I don't know that for sure, but I think that's the case. So if you know requests, you'll get this done just fine. So for my API test, I just want to test login here. So I'm saying I have a API request context. This comes from Playwright itself. And I have fixtures behind the scenes that set this up. Just take it on faith. This is a session object. Not my user and my base URL. So I can say bulldoggy API post login with my username and password. Verify that my response is OK. Verify that my response URL is this. Go into the storage state. Try to get the cookie out. Make sure the cookie has a certain name and has a certain value. Like, again, kind of basic test. But just making sure that if I post a login, I actually get a cookie back. Finally, a UI test. This is kind of like historically been the more intense kind of test that we have. This one will actually load up a browser and step through these things. So here I want to do a UI test for testing successful login. I have the page, which comes from Playwright, that represents the browser page, and the user who I'm logged in as. When I write my tests, I follow the arrange act assert pattern. Have people heard of arrange act assert? Yes. So it's arrange act assert. It's given when then. Basically, it helps keep your test focused on individual independent behaviors. So you set something up, you take an action, and then you make sure that action works. One solid behavior: arrange, act, assert, or given when then. So I always like to write things out kind of verbosely because these are behaviors. Behaviors are meant for people. Makes more sense to me that way. So given the login page is displayed, Playwright call, page.goto. When the user logs into the app with valid credentials, page locator, we're finding, okay, what's the username field, and fill it with text for my username, password, fill it with password, and you don't have to do a raw locator in Playwright. You can just be like, hey, page, get the element by the text login and click it. Yay, cool. So setup, interaction, now we're going to have some verification here. So then the reminders page is displayed. How do we know the reminders page is displayed? Well, we expect the page to have a title, reminders, the bulldoggy app. We expect the page to have a certain URL with that /reminders. We expect the page to have this logo being visible, to have the text in the title, bulldoggy. We expect the logout button to be visible. And what else do we expect? We want the title card to display reminders for your username. So that's a bit more dynamic. I get that field by its ID. I expect it to have a text. I use an F string. Yes, I love F strings. Reminders for substitution, my name. Does this all make sense? Do we see the testing is good? That not everybody hates testing? Okay. Just make sure. If I wanted to run this, because this is live, baby. I did not want it. I wanted this terminal. We can go Python -m PyTest. I can prove it to you that it works. Proof is in the pudding. Tests. I'm only going to do Chromium and headed so you can see it. Let's see if this works. So it's running API test, the UI test, the browser should pop up. That was very, you see how fast Playwright was? Did he even show on the screen? Okay, you saw how it was fast, right? It's freaky fast. All right. We broke the rule of ones. It was amazing. And so 3 tests passed. Like I have now somewhat tested my application. That is awesome. Well, wait, I don't want to just test it on my local machine, because if you can read that. If this application gets more popular and people start using it, I might be getting pull requests, and I'm not always in charge of that. We just had a whole talk yesterday about like vulnerabilities and pull requests and dictators and oh my gosh, right? I want to be able to run these tests whenever there's a change. I want that to be arguably continuous. And so I have created a GitHub action workflow that will run your tests. This is a little tiny. Here we go. Have people used GitHub Actions before? Aren't they the bee's knees? Yes. So if you haven't used GitHub Actions, basically it's automation for your repository. So you can do things like anytime somebody makes a change, you can automatically run tests, or you can run linting. I mean, we had a whole talk about build engineering yesterday. Build engineering given to people in their repositories right here. Boom, it's beautiful. So I love GitHub Actions. And so here I've got a basic workflow. You write them in YAML that says things like, hey, anytime there's a push to main or a pull request, or hey, if you just want to push the big red button, get a Ubuntu image, check out your project, set up Python, install your dependencies, install Playwright because you need an extra command for that. Start your application, cool. Wait 10 seconds for it to kind of wake up a bit, and then you just run your tests. And so now every time I make a change in my repository, the tests run automatically. Continuous integration is beautiful. Yes. Yeah, it's pretty cool. It's pretty cool. It's automation. Automation for the win. I love it. All right. So we've covered a lot. So what did we all just see here? I mean, we saw a very cute puppy picture, but beyond that, we saw that we had a model. There was a database, it was TinyDB. I used Pydantic models to kind of serialize and deserialize those data objects. I chose that because I wanted to be super simple, being better than complex. If I were to more productionalize this, I'd probably use something like Postgres with SQL Alchemy or something. But all that to say, we had a model. We also had a controller, Fast API. It was the thing that received all the requests and puked things out. Mostly it was hypertext it was puking out. Or it was JSON if you were hitting the API. You had those 2 kinds of paths to go. You could have used Flask, you could have used Django, you could have used anything else. I chose Fast API because, and one of the reasons was because it had that nice doc thing out of the box. We also had views. We had beautiful views. Like, I think my app actually looked pretty good. I'm kind of proud of that. It's not like the best, but I was afraid it was going to look like some 90s Frankenstein web app, and it wasn't. It actually looked kind of smooth. How do we do that? We had Fast API, used Jinja templates with static files, a little bit of CSS. I didn't want to go too much into that, but that's what made it pretty. Sent that out to the browser renders it, and then anytime you wanted to change something, we used HTMX to kind of send those interactions back to the Fast API to puke out more hypertext, right? That was the view. So we have model view controller. Cool. Then we had an API. If you want to go in the back door, you can call the API. You have full REST API with open API specs. So not only can you do it, but you can learn about it. And you didn't have to like change your docs every single time. And so whatever client wants to call it can call it. And overall, we decided to test it because development and testing are two sides of the same coin. And we used Playwright and PyTest to develop full stack tests, full pyramid tests, unit, API, and UI. So now, million-dollar question, what were the languages and technologies used to build our application? The model was Python. The controller was Python. The view was mostly Python. I mean, we had to use CSS and HTML. Under the hood, there was JavaScript, but did you see me coding any JavaScript? No, I just used hypertext, which is basically HTML. Slap on an attribute, send it a path, woo, right? So we didn't need ourselves to do the JavaScript. Of the API was Python, and even the testing was in Python. Congratulations, we have achieved full stack Python, everybody. We did it! It's not even 10 a.m. and we've done it! I know, it's so cool. But what about AI? Because it's 2023, and every conference needs to have every talk about AI now, right? What about AI? Like, this is more like a classic kind of web app, a little funky, but if you haven't heard, most AI technologies have Python somewhere in them, just because Python has taken over data science and all that kind of stuff. So even if you're not programming Python, if you're using AI, there's probably Python somewhere baked in there. I actually used some AI technologies when building this web application. First of all, that logo. You think I hired somebody to do that? No. Do you think I did that myself? No. I have a French bulldog puppy. This is her picture on the left. Her name is Suki. She is 1.5 years old. She is a gift from God. I love this dog. She has changed my heart. Oh my gosh, you're lucky you're not seeing more puppy pictures. If you want to see more, come after. But I love my dog. I love my dog so much. I made her the icon of my little demo application for here today. But I was like, I can't just put her face on the application. That doesn't quite jive with the style. So what I did is I used DALL-E to generate an icon for my app. I went there, was like, hey, DALL-E, generate a logo of a French bulldog that kind of looks like a lucky cat. And boom, this is what came out. It's pretty cute, right? So right there, I was able to use AI-based technology to help me in a part of my application development where I was lacking skill. I had an idea, but I couldn't just design this myself. I could tell somebody or something how to design it, and it popped out. And it was just there for me. So all I had to do, I had to make the background transparent, and then I was good to go. Also, my login page. I am not a web developer. I mean, I cosplay as a web developer, and I can get it done, as you've seen. Like, I built this app myself. But I am not well-versed in, CSS. I'm pretty good at HTML, but I'm not, a CSS master. I can't make a pixel art thing of CSS or anything. And so when I came to developing this web app, I was like, oh, crap. I gotta, I want to make it look nice. I want to make it look nice. I don't want it to be janky. So I went to ChatGPT and I said, ChatGPT, generate the CSS and HTML for a good-looking login page. And this is about 80% of what it puked out. The background was originally bluish gray. And so all I did was I changed the color, I changed some of the formatting, I put the logo in there. But I was able to do that in about an hour versus an entire day of fooling around with the HTML and CSS, just trying to move pixels back and right. So this really optimized my whole workflow. And finally, for testing, we could use Applitools, the company I work for, their visual AI technology for testing visuals on the application as well. Most traditional testing tools, even like Playwright, you need to scrape a field and check its text. What Applitools does is you can actually do visual comparisons, as we're seeing here, where we'll highlight exactly what is different. So again, congrats, we have truly achieved full stack Python. So awesome, so cool. so many technologies that we can play with and build with to make the software that we want, and we can basically do it all in Python. It's really cool. So why is this important? I mean, you could probably infer why it's important because we're at a Python conference, but let's yeah. Let's take a bigger picture of like, well, I mean, I could do all these things in Python, but like, should I? Or I mean, is everything I've shown just a party trick, or is this something revolutionary? Ultimately, I go back to the principle simple is better than complex. This principle comes straight from the Zen of Python. If you're not sure what the Zen of Python is, it's a set of guiding language principles for the Python language, and I would also argue for the Python community. If you want to see what the Zen of Python is, if you open up your Python interpreter on your command line, Python, boom, import this. You'll see all 20, there's 20 principles? Something like that. 19, yeah. That's an Easter egg for you. So anyway, import this, you'll see all the principles, and this is one of them. Simple is better than complex. And this is honestly one of the reasons why I love Python more than other languages. Because Python kind of encourages you to do things the right way, the simple way. The syntax is very concise. I feel like it's almost like executable pseudocode. And so I kind of apply that philosophy when I approach software developments. Right? Historically, I've been a software engineer and test. I'm now a developer advocate. I build things, all kinds of things. But when things are simpler, it's easier to get started. It's easier to bring people into that. It's easier to have an impact. And so here are some examples of different people who may want to take a full stack Python approach, where it would be truly valuable to them. What if you are a researcher who needs to visualize and share your data with colleagues, right? Like I've known friends who have done like PhDs in like virology and environmental science and stuff. And at this day and age, like if you're on that track, you are taking a Python course or two in college. Like you don't have a choice. It's part of your program now. These people aren't programmers. They need to munch some data and do some analysis and share that with their colleagues across academic institutions around the world. Do you think they're really going to learn React to build a basic web app for that need? No. They were struggling enough to learn Python. They got it. They have their data. They can use pandas. Why not just use something like Django with HTMX if necessary to share that out? Why would they need to go into JavaScript or PHP to develop a simple website for their needs? Doesn't make sense to me. That's a whole extra set of stuff they shouldn't need to learn. What if you're like me and some of my colleagues in the testing space? What if you are a tester who's developing automation for web apps? And you happen to know Python. Why should you have to go learn Java in order to use Selenium? I don't know, you shouldn't have to. If you know Python and you can test it, you got Playwright or Selenium Python. And PyTest, PyTest is really cool. Here's another one. What if you are a cosplayer? You go to AnimeCon, wherever it is. You want to dress up as Miles Tails Prower with your friend Sonic the Hedgehog, right? And you're going to be like doing little hardware Adafruit components to make your costume light up or something. You can program that in Python too. What if you are a newcomer to computing and programming and software, and you want to do cool stuff, but you only know Python so far? Right? You could be a high school student or maybe a career changer, and you've been doing the Hello World program, and you've been modding by 2, and you're figuring these things out, and you're like, oh wow, it'd be really cool if I could build a web app to do this. It would be soul crushing to then go to that person and say, no, you can't do that. Well, why? Because you need to learn a whole different thing than what we taught you. That's really lame, right? Really lame. I think back to one of Kojo's keynotes where he talked about how not everybody is on the software engineer track. It's okay just to use Python for programming to do cool stuff. That is totally okay. Not everyone is meant to be a software engineer. And so why should we be in an ecosystem of software development that limits people based on, oh, well, you have to use this to do this or that to do that? That's not fun. That's not cool. And ultimately, what if you just want to use Python? What if, regardless of any other reason, What if you just like Python, you like the language, you like the values, you like the community, you like the conferences, and you just want to do cool things in Python for the heck of it? Why not? That's me. I'm a bona fide Pythonista. I do Python because I like Python. Why not? Why should I be inhibited from that? Python, pardon me. Python is an amazing tool. It transforms us from programmers into problem solvers. You can basically do anything in Python. I mean, there's that XKCD comic where it's like, I can import fly, and now I'm flying, right? That's been the running joke of Python forever. You can literally just import anything and do stuff. That is the magic of Python as a language. It truly is the best language for doing everything together. And so we are no longer just programmers, but we are problem solvers. We have the tools and the expertise, and if we don't yet, we have the ability to gain that through Python. And so that is what I consider to be full stack Python. Not just that I can build a cool little web app, but that I can do anything I want. So thank you so much, everyone, today for attending my keynote. Again, my name is Andy Knight. I am the Automation Panda, Principal Developer Advocate at Apple Tools, and Director of Test Automation University.